Happy St. Patrick's Day, 3B. It's time to learn some chemistry. So I guess if you could get your chemistry notebook out, you can pause this video at any time if you need to get supplies. I'm going to be working you through a problem on how to balance the equation and then how to find the limiting reactant and just kind of remind you guys how to do everything. So if you guys could check Rediker regularly and go ahead and find your chemistry notebook, we can go ahead and get started. So right here we have a balanced chemical equation. I'm going to go ahead and cover up an area here that you don't need to see yet. There's your equation. So if you want to pause the video now and write that equation down in your notebook and balance it, you can do that. I'm going to go ahead and balance it for you. So hopefully you put a 4 here, and a 5 here, and a 4 here, and a 6 here. Okay, so just to remind you guys a couple things about this, you know that on the left-hand side we have reactants, and on the right-hand side we have products. So when we're working on limiting reactants, we're trying to figure out which one of these reactants is going to run out first. So some information you need now that you have the coefficients in the balanced equation, you need to know how much of each reactant you have on hand. So right now, I'm going to tell you you have 3.25 grams of this reactant. My writing is going to be a little messy with the mouse here. So 3.25 grams of this reactant. And then you're going to have 3.5 grams of this reactant. So we'll go ahead and label that on the equation. You should do that in your notebook as well. So 3.50 grams of this reactant. So you want to figure out which one of those reactants is going to run out first. I'm going to recommend that we figure out how many grams of this product we have. So here is our product we're going to calculate. Now we're going to do some stoichiometry that's going to go from this reactant over to this one. We're going to calculate that, and then a separate calculation where we're going to go from this reactant to the same product. So if you want to pause the video and go ahead and do that calculation, you can resume it whenever you want to check your answer. So I'm going to go ahead and do that work down here. So here's your first calculation. You can see some things that are canceling out. So I'm starting with my 3.25 grams of this reactant. So I have grams of that reactant canceling out with grams. Then I have moles of that reactant canceling out with moles. And you can see my mole ratio here. I'm getting from my coefficient 4 there and my coefficient 4 right there. So that's why I have a mole ratio of 4/4. And you can see that moles cancels out with moles. And I'm left with grams of that product. So when you push that in your calculator, you're going to get 5.73 grams of that product. So I'm going to go ahead and write that in, 5.73. And that's going to be grams of nitrogen monoxide. And then you should have also used your stoichiometry to go from oxygen over to nitrogen monoxide as well. So I'm going to go ahead and show you that calculation. Okay, so you're starting with 3.50 grams of the other reactant, and so I'm going to go ahead and cancel the grams of oxygen out. I'm going to cancel moles of oxygen out. I know that I'm getting my 4 from the 4 right there. I'm getting my 5 from the 5 right there, so that's where our mole ratio comes from. And I'm going to cancel out moles with moles. And I punch in my calculator again. I have grams of nitrogen monoxide, so you can see it's the same product I'm calculating. So this time I get 2.63 grams of that same product. And you can see right away that 2.63 is less than 5.73. So you're doing their comparison right there. So you can see right away that this one right here, your oxygen, is your limiting reactant. Okay, so be careful you don't call this your limiting reactant because that's a product. So I'm going to label my limiting reactant oxygen, and I'm going to label my excess reactant over here because that's the one I have extra of. So this one's excess. Okay, so at this point, it should feel just like your homework did. You had homework on page 284, number 34, I think it was, and you had to find the limiting reactant. And so at this point, the problem should look just like that. Now, the thing we're going to add to that lesson today is that now that you know which one is your limiting reactant and which one is your excess reactant, the next question we want to ask is, how much extra do we have of this excess reactant? Because remember, when we say it's excess, it means that we have more than we need. So this 3.25 grams, we know that since we've called this excess, we know that we don't really need all 3.25 grams. We're going to have extra. So the question is, how much extra will we have? So in order to calculate that, we're going to take our limiting reactant, because we know we're going to use all of that up, and we're going to go from this much limiting reactant, and we're going to calculate how much of this excess reactant do we actually need. So our last stoichiometry we're going to do, we're going to go from here over to here. So that's a new calculation we've never done before. So if you haven't, if you want to go ahead and do that calculation in your notes, calculate 3.50 grams of oxygen, and then go over here and calculate how many grams of this you actually need. Now remember, this is how much you have, but that's not necessarily how much you need. So go ahead and calculate that, and then I'll show you the answer down below. Okay, so here's your stoichiometry for 3.50 grams of oxygen. So I'm going to start there. I'm going to cancel out grams of oxygen and grams of oxygen. Then I'm going to cancel out moles of oxygen with moles of oxygen. Remember your mole ratio, the 5 comes from right there, and the 4 comes from right there. So there's your mole ratio. And then I'm canceling out the moles with moles. And then I'm left with grams of NH3. Now that's my excess reactant. So when I actually punch that in my calculator, I'm going to get 1.49. So that's 3 sig figs, because everything was given in 3 sig figs. So 1.49 grams. And remember, this is grams of NH3. That's my excess reactant. So let's look at these two numbers we have. We have 1.49 grams of NH3. That's how much NH3 we actually need. We have 3.25 grams of NH3. That's how much we have. So if we have 3.25 and we only need 1.49, it should make sense that if we subtract those two, so if we take, let's see if I can do the mouse here. So 3.25 grams, that's how much of our excess reactant we have. So it's going to let me write here. There we go. Oops, that says 3.25 grams. That's how much we have. And then over here, this is how much we actually need. So we're going to subtract 1.49 over here. And when we do that subtraction, it's so messy. When we do that subtraction, we should be getting 1.76. So we can see 1.76. That's how many grams of our excess reactant we're going to have left over. So the key to calculating excess is that you have to use the limiting reactant to figure out how much excess you need. And then you're going to always take how much you have minus how much you need equals how much you have left over. So this 1.76, this is how many grams of NH3 that is considered extra, because we don't need it all, because our limiting reactant says that we only need 1.49. Okay, thanks for watching. I'm going to have an assignment posted on Rediker. There's a worksheet there. You don't have to print the worksheet out. You can just work the problem from the worksheet there. If you don't have a printer, you can work it right there in your notebook. And like I said, just keep checking Rediker, and we'll keep learning chemistry. See you guys.